Hey everyone, welcome back to Bear It In Mind. This video is going to summarise the whole of the memory topic. This is designed to give you an overview of the whole topic to help your revision. If you want more in-depth explanations of any part of memory, you can find a full playlist of videos on each section on the Bear It In Mind YouTube channel. And if you want more help with your revision to study smarter and save you time, you can join Bear It In Mind, where you'll find a variety of resources from interactive quizzes, exam paper walkthroughs and exemplar answers and much more, and the link is in the description. Alright, let's dive in and summarise the memory topic. First, let's get the big picture of the topic so that we can see how it breaks down. Memory can be broken down into three sections: models of memory and long-term memory, explanations of forgetting, and eyewitness testimony. The multi-star model of memory was proposed by Atkinson and Shiffrin in 1968. This model explains memory as a linear process, moving through three distinct stages: sensory register, short-term memory, and long-term memory. You need to know the coding, capacity, and duration of each store. Let's break down each part. First up, we have the sensory register. This is where all sensory information like sights, sounds, and smells is initially stored. It has a huge capacity to detect all sensory input, but the information only lasts for a very short time, about a quarter of a second for visual information and 3 to 4 seconds for auditory information. If we pay attention to this information, it moves into the next stage, short-term memory. This is where we hold information temporarily. We know the coding of short-term memory is mainly acoustic from Baddeley's 1966 research. He found that participants had more difficulty remembering acoustically similar words in the short term, suggesting short-term memory relies heavily on sound-based encoding. We know the capacity of short-term memory from Miller's 1956 research, which found that people can typically hold 7 plus or minus 2 items in their short-term memory. This was supported by digit span tasks, where participants were asked to recall sequences of numbers of increasing length. We know the duration of short-term memory from Peterson and Peterson's 1959 study, where participants were given trigrams to remember and asked to count backwards to prevent rehearsal. They found that after about 18 to 30 seconds, recall dropped significantly, showing short-term memory has a short duration without rehearsal. If we rehearse it enough, it moves into long-term memory. This is where information is stored permanently with an unlimited capacity. Long-term memory is primarily encoded semantically, meaning it stores information based on its meaning, not its sound or appearance. And we know the coding of long-term memory is mainly semantic from Baddeley's 1966 study. He found that participants had more difficulty recalling semantically similar words after a delay, suggesting that long-term memory stores information based on meaning rather than sound. We know the duration of long-term memory can be very long-lasting from Barrick et al. In 1975, who found that participants could remember the names and faces of classmates from high school even up to 50 years later, showing that some long-term memories can last a lifetime. The case study of patient HM supports the multi-star model because after surgery to remove parts of his brain, including the hippocampus, he could no longer form new long-term memories, but his short-term memory remained intact. This suggests that short-term memory and long-term memory are separate stores, as the multi-star model proposes. The case study of KF challenges the multi-star model because after a brain injury, his short-term memory for verbal information was impaired, but his short-term memory for visual information remained intact. This suggests that short-term memory is not a single unitary store, as the multi-star model claims, but may have multiple components. Furthermore, the case study of Clive Wearing challenges the multi-star model. This is because, despite severe damage to his episodic memory, he couldn't remember personal events, his procedural memory, for example playing the piano, remained intact. This suggests that long-term long-term memory is not a single store, as the multi-store model proposes, but consists of multiple types of long-term memory. The multi-store model can also be criticised because much of the supporting research, like Peterson and Peterson's study, uses artificial tasks, for example recalling meaningless trigrams in laboratory settings, which lack ecological validity. This means the findings may not accurately reflect how memory works in real-life situations. Next is the working memory model. This was proposed by Baddeley and Hitch in 1974. This model helps us understand how we temporarily store and manipulate information in short-term memory. Unlike the multi-store model's idea of short-term memory as a passive store, the working memory model sees it as an active multi-component system. There are 4 key components in the working memory model. First up, the central executive. Think of this as the control center of the working memory system. It's the boss of the system. It directs information to the other components and allocates attention to tasks. It's crucial because it decides where your mental resources go, but it has a very limited capacity. Next, we have the phonological loop. This part stores and processes verbal and auditory information. It's split into 2 parts: the phonological store, which holds speech-based information like an inner ear; the articulatory control process, the inner voice. This is where we rehearse verbal information, like repeating a phone number to remember it. Another component is the visual spatial sketchpad. This component stores and manipulates visual and spatial information, so it helps you picture things like the layout of a room. Then there's the episodic buffer. This was added to the model in 2000. It integrates information from the phonological loop, the visual spatial sketchpad, and long-term memory into a coherent sequence. The case study of KF supports the working memory model because after a brain injury he showed impaired phonological loop functioning, difficulty with verbal tasks, but relatively intact visual spatial sketchpad abilities. He could still process visual information. This suggests that the phonological loop and visual spatial sketchpad are separate systems, as proposed by the working memory model. Further support comes from Paul et al. In 1993. In their study, they used PET scans to investigate brain activity during tasks involving the phonological loop. They found that the articulatory control process, the inner voice, was located in Broca's area, whereas the phonological store, the inner ear, was located in a different area of the brain. This supports the working memory model by providing evidence for the separation of the phonological store and the articulatory control process, showing that they rely on distinct brain areas for different functions. Additionally, dual task studies also provide support for the working memory model by demonstrating that people can perform 2 tasks at the same time if they involve different components of working memory. For example, one task using the phonological loop and another using the visual spatial sketchpad. But they perform them worse if 2 tasks use the same component. This suggests that the phonological loop and the visual spatial sketchpad are separate systems, as they can operate independently without interfering with each other. However, Wolbers et al. In 2011 found that people blind from birth could use touch to understand spatial layouts, activating the same brain areas as sighted individuals. This suggests that spatial awareness is separate from vision, challenging the working memory model's visual spatial sketchpad and implying it may need to be split into distinct visual and spatial components. The central executive has been criticised for being too vague and poorly defined, as it is unclear exactly how it controls and coordinates the other components of working memory. Researchers argued that it lacks a clear structure and its functions are not easily measurable or specific enough to be fully understood. Next we come to the types of long-term memory. There are 3 types you need to know: procedural, episodic, and semantic. Procedural memory is the memory for skills and actions. Think riding a bike or playing an instrument or typing on a keyboard. What's interesting about procedural memory is that it operates automatically, without conscious thought. You can't consciously inspect it. It's also non-declarative, and it doesn't reference a specific time or place. It's just your ability to perform actions you've learned over time. Next up, we have semantic memory. This is the memory for facts, concepts, and general knowledge, like knowing that Paris is the capital of France, or that water boils at 100 degrees Celsius. Semantic memory isn't tied to a specific time or event, and while you can consciously inspect and recall these facts, they don't come from personal experiences. It's more about the knowledge we accumulate over time. Finally, we have episodic memory. This is your memory for personal experiences and events, like remembering a birthday party or a holiday. Episodic memory is linked to a specific time and place, and it's what allows you to recall events from your life. Unlike procedural memory, you can consciously inspect it, and it is declarative, and they're tied to specific moments in time. Let's consider the evidence for the types of long-term memory. The case study of HM involved the surgical removal of parts of his hippocampus to treat epilepsy, which resulted in severe anterograde amnesia, impairing his ability to form new episodic and semantic memories. However, HM was still able to form new procedural memories, such as learning motor skills, providing evidence that episodic, semantic, and procedural memories are separate systems without long-term memory. Furthermore, the case study of Clive Wearing provides evidence for the different types of long-term memory. He was a musician who suffered from severe amnesia due to a brain infection, and he had profound difficulty forming new episodic and semantic memories, while his procedural memory remained largely intact, allowing him to still play the piano. This provides evidence that different types of long-term memory are separate systems that can be independently affected by brain damage. However, research supporting the different types of long-term memory, such as the case studies of HM and Clive Wearing, can be criticised for being based on individual cases which may not be representative of the general population. Now we come to explanations of forgetting, and there are two you need to know. First up, interference theory. The interference theory of forgetting suggests that forgetting occurs because other information confuses or disrupts our memories, and this is more likely to happen the more similar the information is. There are two types of interference: proactive interference, where old information disrupts the recall of new information, and retroactive interference, where new information disrupts the recall of old information. Remember that proactive is the past interfering with the new, and retroactive is the recent interfering with the old. In their 1931 study, McGough and MacDonald investigated the role of interference in forgetting by having participants learn lists of words and then introducing a second list with varying degrees of similarity to the first. They found that retroactive interference occurred when the second list were synonyms. In other words, most similar to the first list, leading to greater forgetting of the original list, supporting the idea that interference can hinder memory retrieval. In their 1977 study, Badley and Hitch asked rugby players to recall the names of teams they had played against during a season, with some players having missed games due to injury. They found that players who had played more games, and thus had more interfering information, forgot more details, suggesting that retroactive interference from the additional matches hindered their ability to recall earlier games. However, both those studies have some limitations. For example, McGough and MacDonald's laboratory experiments lack ecological validity, as the artificial task of word list recall may not reflect real-life memory interference. Badley and Hitch's study with rugby players, while more ecologically valid, cannot easily establish a cause and effect relationship, as it's unclear whether the interference was truly due to the number of games played or other factors such as fatigue or motivation. Finally, in their 1971 study, Tulving and Sotka found that participants forgot the words in an original list that they had learned, the more lists of words they had to learn afterwards. But when participants were given a cue to help recall the original list of words, recall improved significantly. This suggests that while interference may hinder memory retrieval, the information is still available in long-term memory, and retrieval failure due to lack of cues rather than interference may explain forgetting. The other explanation of forgetting is retrieval failure. This is when information is not retrieved due to the absence of cues at the time of recall. Context-dependent forgetting occurs when the external environmental cues at learning are different from the external environmental cues at recall. State-dependent forgetting happens when internal states at the time of learning differ from those at recall. This could be psychologically or physiologically. In their 1975 study, Godden and Badley investigated context-dependent forgetting by having scuba divers learn and recall words either underwater or on land. They found that recall was better when the learning and retrieval context matched, i.e., learning and recalling underwater or on land. In Lowe's 1986 study, participants had to memorize a map and directions to follow in either a drunk or sober state. The study found that recall was better when participants were in the same state of encoding and retrieval, supporting the idea of state-dependent forgetting, where a mismatch between internal states of learning and retrieval can hinder memory recall. One of the strengths of retrieval failure as an explanation of forgetting is that it has been applied in the cognitive interview, where eyewitnesses are encouraged to restate the context of the event by mentally returning to the scene. This process uses cues to trigger memory, enhancing recall by providing additional retrieval cues that can help overcome retrieval failure. One of the criticisms of the retrieval failure explanation is that the context or state you are in when recalling a memory has to be dramatically different from the context or state you encoded the information in. As a result, the explanation doesn't account for why we might forget in circumstances that aren't so dramatic, in circumstances where things are fairly similar. Eyewitness testimony is a first-hand account of an event, often a crime, but its accuracy can be affected by misleading information. This includes two key factors: leading questions and post-event discussion, both of which can distort the original memory before recall. Leading questions are those that suggest a certain answer, often used by police or lawyers, and can distort an eyewitness's memory. In a 1974 study, Loftus and Palmer showed participants car crash videos and asked them to estimate the speed using different verbs. Results showed that the wording influenced speed estimates, demonstrating how language can alter memory in eyewitness testimony. In Loftus and Palmer's second experiment, participants who heard the word smashed in a speed-related question were more likely later, falsely, to recall seeing broken glass, even though there was none. This shows how leading questions can not only distort memory of details like speed, but also create false memories of events that never happened. Post-event discussion is when eyewitnesses talk about an event after it has occurred, which can lead to the distortion of individual memories. In Gabbert et al.'s 2003 study, participants who viewed different angles of a crime video and then discussed it were more likely to recall details they hadn't actually seen. The study found that 71% reported misinformation, highlighting how memory can be influenced by others. Let's now evaluate misleading information. Loftus and Palmer's and Gabbert et al.'s studies were conducted in controlled lab settings, allowing researchers to isolate variables and establish cause and effect. This high level of control and replicability strengthens the argument that misleading information can distort eyewitness testimony. However, a major criticism of studies like Loftus and Palmer and Gabbert et al. Is that they lack realism, as participants only watched videos rather than witnessing real crimes, so the emotional impact and seriousness were missing. Research by Foster et al. In 1994 showed that eyewitnesses were more accurate when they believed the event was real and their responses mattered. Another factor that is thought to influence the accuracy of eyewitness testimony is anxiety. Research suggests that anxiety can negatively affect recall as the fight or flight response narrows attention and impairs memory. This is evident in the phenomenon of weapon focus, where a witness's attention is drawn to a weapon, reducing their ability to remember other details of the crime. In a study by Johnson and Scott in 1976, participants overheard a discussion in a waiting room before witnessing an event with two conditions. In one, a man left with a pen, and in the other, a man left with a knife covered in blood. Later, participants were asked to identify the man from photographs, and those in the high anxiety condition were less accurate compared to those in the low anxiety condition. Some research suggests that anxiety can have a positive impact on eyewitness testimony, as the heightened alertness from the fight or flight response strengthens memories of stressful events. Ewell and Cutshall in 1986 investigated eyewitnesses to a real-life shooting in Vancouver and found that those who were most distressed at the time of the event had the most accurate recall, with 93% accuracy. This study challenges previous laboratory research suggesting that anxiety can have a positive impact on eyewitness testimony in real-life situations. Furthermore, Christensen and Hubinett studied 22 real bank robberies and found no evidence that high arousal negatively impacted recall. Witnesses accurately remembered details even 4 to 15 months later, suggesting that highly emotional events may enhance memory. Now let's evaluate this research into anxiety. A strength of the studies by Ewell and Cutshall and Christensen and Hubinett is that they were conducted in real-life settings, providing more ecologically valid results compared to artificial lab studies. Participants experienced actual stress and anxiety, making their eyewitness testimony more applicable to real-world situations. Whilst these studies offer high ecological validity, they lack control over extraneous variables. Factors such as post-event discussion could influence eyewitness memory, and in Ewell and Cutshall's study, proximity to the crime may have also affected recall, making it difficult to establish a clear cause and effect relationship between anxiety and memory accuracy. The cognitive interview is a questioning technique designed to improve the information an eyewitness can retrieve about a crime. The technique involves 4 key parts to help eyewitnesses retrieve more accurate information. Reinstate the context. Eyewitnesses are encouraged to mentally return to the crime scene, recalling environmental and emotional details to trigger memories based on the encoding specificity principle. Report everything. Witnesses should provide all details, as even seemingly irrelevant information may aid in recalling important facts. Reverse the order. Recalling events in reverse order helps counteract the recency effect and the influence of schemas, leading to more accurate recall. Change perspective. Witnesses are asked to recall the event from various perspectives, disrupting schemas and encouraging a fuller report. The enhanced cognitive interview, developed by Fisher et al. In 1987, builds on Geiselman's work by emphasizing the importance of building rapport with the eyewitness to ensure they feel psychologically comfortable and more likely to recall accurate details. Now let's evaluate the cognitive interview. Geiselman et al. In 1985 found that participants interviewed using the cognitive interview recalled more details compared to those who underwent a standard interview. However, there was no significant difference in the number of errors made in each condition, showing how effective the cognitive interview was. Further evidence comes from Fisher et al. In 1989, found that detectives trained in the cognitive interview gained 63% more information than untrained detectives with over 90% accuracy. Furthermore, Konkin et al. In 1999 conducted a meta-analysis of 42 studies involving nearly 2,500 interviews and found that while the cognitive interview increased correct recall, the enhanced cognitive interview led to more errors than the original version. A limitation of the cognitive interview is that it's time-consuming, requiring both longer interview durations and additional officer training. Despite its effectiveness, time pressures and limited resources often prevent police from conducting full cognitive interviews. And breathe. That's the whole of the memory topic. For more resources to help you with A-level psychology so that you can study smarter and save you lots of time, go and check out the Bear It in Mind website. I hope you enjoyed this video and we'll see you in the next one.